Okay. Anything else from, did everybody get their quiz back? Did you take the quiz? Laura's not here. Jack's not here. Nicholas is not here. Aaron is here. Okay. Let's see. Oh, so I can give you a copy of it if you want. Anybody else want to? Anybody else miss the quiz? Want a copy of it? Anybody? Okay. Does anyone need a copy of the practice test? No way. Okay. Everybody else got a practice test? That wants one? Okay. All right.
If we get it correct, that means we only got partial credit. Right?
Yes.
Okay.
Yes.
Gotcha.
Believe it or not, I used to write correct mistakes. That adds up over time. So I just put correctly in. Okay. Ah, you're still alive. Yay. Oh, happy. Okay, sorry. Yes. 40 from 5.5. Everybody understand what's happening tomorrow, right? Test is happening tomorrow. So today is the day. Today is the freaking day. Dear God, and I apologize if I'm come off as somebody that's not approachable or something. You guys, maybe you're just all very quiet people. I don't know. You can ask any damn thing. You understand? Anything. You can say, you don't have to say it like this. But you can think, my God, this guy made no sense. What comes out of your mouth is, can you re-explain this thing? Can you do some problems with this thing? Can you do this specific problem? It could be any level of question. You guys with me? Okay, we'll see. Okay. So number 40? Okay. Find all complex solutions, real and imaginary. Okay. So this one is kind of funny. What's your list of possible roots? In fact, I mean, so this is section, what was it again? 5.5? Cool, then we know everything. 5.5, we know everything. What does Descartes say? You're all like, oh, he said a lot of shit when he was alive. He mumbled something about a fly in the wall, man. That's all I know. Are there any sign changes in the polynomial given in number 40? So what does that mean? There are no positive real roots. So there can only be negative real roots. And what's the last number? 1. What's the only factors of 1? 1. So no positive roots, and the only number is 1, so the only thing I can try is negative 1. Now, to be honest, number 40. Well, let's try it. Can everybody do that? If you haven't done number 40, go ahead and try to do negative 1 synthetically. And then I'll point out something about this specific problem because nobody said anything yet. Oh, that's different. I don't want that. Shit. Turned it to the point where it's trying to guess what I'm trying to say. I don't want that. There we go. This is kind of cool. It'll translate my scribble to like text, which is sort of nice sometimes, but when I try to make symbols, it tries to guess what it is, and it's not an arrow, little dude. It just isn't. Okay. 1, 1, 1, 1. 1. Right? Keep going. Does it work? Somebody says no. Negative 1, 0, 0, 1. Negative 1, 0. Yes? That looks like it works. How do I know that? What is that? Why does that mean it works? What do you mean? What does that mean? What does works mean?
No remainder.
No remainder. That tells me that what I just divided by goes in evenly, which means that what I just divided by is a factor. So what do we know so far? What does this relate to? X plus 1. And what's left here, considering it started as a cubic, right? What's this the coefficient of? x squared, plus, look at me pointing at it. Here's old man, you ready? That one. No, sorry. He's got to take a while to get used to this. That means no x's, yes, plus 1. Have we gotten any answers yet? Any zeros? Yes. What's the 0 we know so far? -1. How many zeros total should there be? 3. Were there any more -1s? No, because can you factor this? You can if you use complex numbers. So you can do this one of two ways. You could set this equal to 0 and solve it. You could factor it. You're going to get 2 complex answers. Are you guys with me? No? So does anyone notice something from the very beginning of this problem? When do I have to use synthetic division? When the thing they gave me, I can't just directly factor it. Can anyone tell me, can you factor number 40, please, dear God? How many terms are in number 40? 4 terms. So what method might work? Grouping. Do you guys see how you can take an x squared out of the first, x plus 1, plus you can take a 1 out? Grouping will work. Maybe, okay. Then number 41, for example, I know I probably didn't assign it, I don't care. Number 41, would grouping work? You can very quickly see, will grouping work? Will the numbers? No, grouping won't do shit for me. So then I make a list of all the possibilities. You can look at Descartes if you want to. Descartes will actually be nice here. But have you guys noticed, anytime the signs are all the same, Descartes kicks ass. Anytime the signs perfectly alternate, Descartes kicks ass. Because what's both parts of Descartes' rule? You look at the polynomial I give you, and you look at how many sign changes there are. It talks about the positive roots. The possible positive real roots. How do you investigate the possible negative real roots? Make x negative. So look at 41. If you make x negative, won't every other thing change sign? So won't they all have the same sign? Won't there be no sign changes? So there's no negative roots for number 41. So when you make your list of possible things, help me out. Look at number 41. I know I probably didn't assign it. I don't care. Can somebody make the list of possible rational roots? What number are you looking at to do that? 26, yeah. So what do you get? I'll start us off. 1, 2, 13, 26, yes. And now, what does Descartes do for me? There's 1, 2, 3 possible positive, or 1. But when I look at the negative, does everybody see what happens when I look at the negative? What would happen to this polynomial if I put a negative into it? When I cube a negative, does it stay negative? Yes. When I square a negative, does it stay negative? No, when I square a negative real number. When I square a negative, it becomes positive, correct? Therefore, the x squared piece will not change the sign. It'll stay the same sign. When I put a negative in for x, x is obviously negative, and the 26 don't care anything. Are you guys with me on this? So I'm trying to show you a bit of a shortcut. Descartes, when it works, I mean, it always works, but when is it useful? Either when the original, like number 40, has no sign changes. Kick ass. It's going to automatically cut my list in half. Or, on number 41, when there's nothing but sign changes. Descartes' going to kick ass. Because then there won't be any negative real roots. Okay, maybe. So now my list just becomes, there's no negative real roots, so my list just becomes these. Just the positive ones, right? So I just have 4 to try. Maybe? Screw you, Jeff. Yes. Sorry.
Could you explain how the upper bound works?
Oh, okay, sure. I don't. Well, let's see. Okay, let's try this. Let's synthetically divide by 13. I have no idea if this is going to work. So I'm looking at number 41, right? Can somebody help me? What goes next? 1. Negative 8.
25.
25.
Negative 26.
Negative 26. Okay, let's see what happens. 1, 13, 5, 65. 90? Who knows? 1300 minus 130 is 1170? Big positive, yes? What does that mean is true about 13?
Or it doesn't factor.
Does in fact, 13 doesn't work. What else does this mean? They're all the same sign, correct? What does that mean? 13 is an upper bound. So which number do I not have to try? 26. So I just eliminated 2. 13 didn't work. And 13 is an upper bound. So screw you, 26.
And if they were all negative, it would be a lower.
No. If I divide by a positive, then if there's no sign changes, it's an upper bound. And if I divide by negative, if there's nothing but sign changes, it's a lower bound.
Okay.
So divided by positive talks about upper bound. Divided by negative talks about lower bound. Look at this.
Why is the 1 and the 25 positive and not negative?
Say again, sorry?
The 1 and the 25?
Oh, this was p of negative x. That wasn't the polynomial that they gave me. Look at number 41. Look at number 41. That's the one I'm working. Why did I do this? What did this relate to? That was Descartes' business, yes? So I don't know where my eraser is. Too bad. I'm modeling exactly the kind of shit I don't want you to turn in. Yes? Use a pencil. Okay. So again, in your homework, even if it says nothing about bounds, as you're trying shit, you can interpret the answer to be a bound. It could help you. Do you have to? No. You only should do it if you'd like your homework to be done quicker. If you don't care, then don't use it. It's fine. Now on a test, what I'm going to do is a lot like what I've done on the handouts. I'm going to say, show that 7 is an upper bound. And then you'll do it. And then everything above 7 in your list, you can just cross out. Yes? I'm going to give you a problem, and I'm going to tell you this right now. I'm going to give you a problem where Descartes actually works beautifully, which means you can cut your list in half from the beginning. You with me? So your list will probably start off as 16 things. Then you're going to cut it in half because of Descartes. Then you're going to cut some off because of a bound. Are you with me? And then you'll be left with like 3 or 4 that you have to try. So you're not like going insane with this long ass list of things to try. Yes? And the person next to you gets lucky, like, God damn it, I don't know yet. That's the worst. Okay. Maybe? Because you're going to have a long list of stuff to try, correct? You want methods to cut it down. We have 2, Descartes and bounds. Those both could cut down the size of my list. Okay. So now I'm just going to try 1 and 2, right? For number 41. Okay. So then try 1 and 2. Okay. So that was number 40, and then I kind of looked at 41 just to explore this idea further. Anything else? Hopefully so, or else today's going to be really short. Yes? 5-4? Let's all find out together. There we go. Oh yeah, okay, this one. So I'll tell you what we decided on before. So we've talked about this problem and the easier way to go about this. So let me ask you this: if I told you, and again, you guys can you guys remind me if I have a box, rectangular box, length, width, height? What's the volume? Length times width times height. So you gotta know that shit. It's just a formula you gotta know. You should have come in knowing it, and now you know it. So use it. So if I told you that the length is 8, and the width is 10, and the volume is what you got, Jeff? I don't know, 160. Could you figure out what the height is? Why? What would you do? What would you do? What would you do? Divide what? Okay, cool. So you can take the volume divided by the length. That's a good first step. And then take that and divide by the width. So then I know what the height is, yes? Or couldn't you multiply those together and then divide the volume by that and just get it in one fell swoop? Fell swoop. You guys ever heard that book? Some of you guys may. Okay. It's a real fart smoke. I'm a smart fellow. So I could do the exact same thing here, right? Do you guys see this? I would highly recommend this second method. So look at number 67. What was the first thing somebody told me to do? The first thing somebody told me to do was to divide the volume by the length. How would you do that on number 67? Divide the volume by the length. You're surrounded by the book. There. Well, not really surrounded. And over there. Yes. Maybe I'll make that one the book too. How's that? Is that better? I'm not gonna. I don't know which monitor that is. Screw it. That'll take me like 20 minutes. Volume is 12x cubed plus stuff, right? Length is 2x plus 3. You could divide those. If you synthetically divide, why does that kind of suck?
Because you have to factor and then multiply the result.
Divide the result by 2, right? That's the whole thing, because you're not divided by something. So what I would highly recommend is to do it this second way. Multiply the length and the width, and then divide the volume by that long division. That is better than 2 kind of gross synthetic divisions, right? Does it make sense? So again, I need you to understand, everything I just did, this whole list, this 8, 10, and 160, I just made a simpler problem. And then I said, brain, what would you do? And my brain, your brain said, divide by that shit. Oh. So then I'm going to do the same thing with the weird-ass variables. I need you to understand this. What are variables? Numbers I don't know yet. So if I just create a little side problem, I'm not changing the problem, I'm just creating a simpler problem. Why is it simpler? Because it's freaking numbers. Now my brain can latch onto it, and I go, what did my brain just do? Oh, it divided. Oh shit, let me do the same thing with the freaky ass stuff. Yes? I don't know if you guys understand, that's completely legal. There's not a damn thing wrong with that. Solve a simpler problem. It's one of the best freaking things in the world to do with word problems. Put numbers in, and then see what your brain does. And then do the same shit with the weird shit. Okay, maybe. Because I understand, when you read that shit, when you first read that, you're like, how the hell would I know? I don't know a damn thing. But then when you give yourself, oh, I know everything. The volume is the multiple of all the other 3, so if I divide by the 2 they gave me, I must get the third 2. I wouldn't see that until I gave myself some numbers. I'm like, oh.
69 were the same thing.
Same exact problem. 69 is the exact same problem. Different numbers, same problem. Yeah. I like it. It's wide open. Anything you guys want to talk about. Do you have homework problems that gave you trouble? Do you have processes that you don't understand still? Is there anything on the practice test that didn't make sense? If not, that's awesome. We're all going to kick ass. Yes. Okay. So first thing, end behavior. Really quick. Do you guys understand why we call it end behavior? When does end behavior kick in? At the end. It's crazy. When x gets really big, negative or positive, correct? So if I have this function here. When x is really small, all this shit can do weird shit. When x is really small, this is really small, and these have this is really small. These have a chance to shine. So in the middle, it can do all this wobbly shit. What must it do when x gets really big? When x gets really big, when x is 18 trillion, I need you to understand this. When x is 18 trillion, these don't mean shit. This is the only one that means anything. 18 trillion squared is really big, yes? 18 trillion cubed, that other guy is nothing. Turn back. Thank you. I need you to understand. So oh God. Okay, here we go. What will this look like then on the ends? There we go. Okay, cool. I like it. It's going to look like a cubic. It's going to look like a cubic. That's the highest power I see. It's the one that's going to dominate when X gets big. When X is small, all the other shit might make it wobble in the middle, right? It's not going to have that many wobbles, but you know it. That's why when I do end behavior, the best way, dear God, please stop doing, I know the book does this stupid shit. Please stop doing this stupid shit. Don't do that. I know the book does it. That's great for the book. I mean, when you see this, can you very quickly see what I mean if I write? You can't, you have to take a moment. See, just draw the picture. That's a perfect way to describe to me what's going on. Yes? So if I gave this problem and I said, what's the end behavior and why? You would say it goes like x cubed, so therefore it looks like that. That is a perfect answer. Make this a 3. There you go. Well, that's sort of a 3. That's a beautiful answer. So let me ask you this. What would the end behavior be for this one?
Oh wait, no.
What's the highest degree term?
Never mind.
Look at Jeff. Jeff is
Upside
being
down.
a true math dork. It goes like negative x to the 6th, correct? That's the highest degree I see. So normally it would be a parabola up, but since it's negative, it's going to be a parabola. Oh my God. It's going to be a parabola down. Now all this other business, all these other things can make the middle wobble. That's where the middle bumps come from. But when x gets big, all this other stuff, all these other things don't mean shit. It becomes a down parabola in the end. End behavior, that's why it only cares about what the highest power is. Because when x gets big, that sucker's going to dominate. It's sort of like me and a friend and another friend are in a room with Bill Gates. And we're talking about how much money to donate. Does it really matter how much me and my other friends donate? No. Freaking Bill Gates. Whatever he donates is going to 1% of my salary. Holy shit! I might as well give nothing. Do you guys understand? Okay, maybe. Okay. So that's Bill Gates, basically, is what I'm saying. Freaking Bill Gates. Okay, sorry. This is so weird. Sorry, I'm getting used to the universe that this form exists in. It doesn't make any sense sometimes. By the way, in a lecture, I'm going to try to be a little more formatted, because I am going to try to upload the PDF of these things into Canvas. So you have the video, and you have the freaking lecture notes. Holy shit. You won't be able to read them in there either, but at least you'll have them. Anything else? Yes? Oh, I'm sorry. You also talking about multiplicity, right? So last thing about this form is weird. It grows. Sorry, okay. Are you guys used to this? Anyone else have Apple? I don't have Apple, so I don't know. It's like a bag of holding. You do more than I thought. No, tough. So multiplicity. So if I had this, what is the 0 of that? What's the x-intercept? 1, 0. And what's it going to do there? Bounce. So it's really just like a parabola, because this is even, that's been moved over 1, correct? You guys with me? If I wanted to be more precise, I could find the x to the y, and blah, blah, blah. It's not my point right now. So this is a even multiplicity. It's going to turn at its root. And we already talked about why, because when I plug a 2 in, I get positive. When I plug a 0 in, I get positive. So it stays positive on both sides. So what if I had this? What's that going to do at its root? It's going to go through. So it's going to look like Jeff. Oh, look at me trying to erase it. Like, it's okay, Jeff. You'll be fine. So it's going to go through like that. It's going to look cubish through its root because it's got an odd power. So, is everybody with me so far? That's the basic idea of, what are you beeping at me for? What's that? Sorry, there's an explosion in the bottom corner. I have no idea what that is. So watch this. What if I made a function that had both of these things in it at once? Yes? So I'd say, what's the roots? What's the intercepts? 1, 0. Negative 3, 0. What's the multiplicity in each? Multiplicity of 1 is 4, and multiplicity of negative 3 is 5. The important thing is this is even, so what's it going to do there? Bounce. What's it going to do at 5? I'm sorry, negative 3. Go through. Because of what we just discussed, right? It's not going to change its sign around 1, but it will change its sign around negative 3. So it's going to go through at negative 3. It's going to turn at 1. Is that okay? Maybe. Okay. Okay. Yes.
Number 7 on the practice set.
Oh, real quick. Sorry. What's the end behavior on this, real quick? And why? Why? Yeah. It goes like x to the 9th, yes? Does everybody see it goes like x to the 9th?
Yeah.
Like x to the 9th, so therefore it's going to look like campus, right? Campus. Can't do that. Shit. Or like a friend of mine calls it draft. Sorry, who was I just talking to a second ago? What's up? What's your
The number 7 on the practice set talks about going through a line and it perpendicular to another one. And that'll mix up between perpendicular and inverse.
Oh. So inverse function.
Like algebraic, not really as much as like what it looks like.
So perpendicular slope. Yes? Okay. So what's true about perpendicular slope? So if one slope was 1/5, what's the other slope going to be? The perpendicular slope? Negative 5, yeah. Okay. Inverse normally either refers to, when I hear inverse, the first thing I think is function inverse, the inverse function, which does not just mean reciprocal, right? So if I had this function.
So perpendicular only applies to linear functions or linear lines?
No.
Okay.
You could have, for example, you could have a circle, you could have something going through the circle that meets at a 90-degree angle. So you could, neither one of those are straight lines, correct? But right when it hits the circle, it's a perfect 90-degree angle at that surface. You kind of with me? So, for us, yes. Yeah, sorry. It's weird when somebody asks me a question, I'm like, well, if you go further, things get really weird. But for us, not quite so much yet. Yes. Okay, good. Let's do that. That I can't do on here. All right, everybody who needs a graphic calculator, let's do a couple things in this thing. Anybody need one? You know what you got to do. Thank you. Thank you. Okay. Oh, let's see. Oh, shit. What do I have there? I have that, so I have a chance that it's this one. Let's see if it's this one. Dude. No. That's fine, actually. I want it there. Okay. So let's see. The problem was number 2. Oh, shit. What was it? Who was this one? I should have done this earlier, but. Oh, yes. Okay. No. Okay. Okay. So let's take a moment. Let's put this sucker in here. X to the fourth minus 0.3 x to the third power minus 37.9 x squared x plus 80.4. Oh my god. Oh, sorry. Move this up. Keep you alive. There we go. Okay. Okay, you guys all with me so far? Okay, so this is, oh, sorry. So you,
It's at the very end. 0.4 and then there's like 2 things.
oh, did I do an extra thing? Oh, I don't know where that came, thank you. Let's see, 80.4, so h equals 3x, 39 squared, 3x cubed, and x to the 4, okay. So I'm asking you to find the zeros. So if I do zoom 6, I'm gonna get some weird stuff happen. Let's see. Ship up. Ship up. Ship up. Alright. Let me see if I can do this. It's that one. That's the PC. That might be this one. Dude. Alright, sweet. Technology. Can you guys, how many zeros do you see?
3 or 4.
If you look really carefully here, there's 2 right there. It actually goes through and goes, right? It peeks its head and goes, I don't like it, and goes the other way. So, how do I find this 0 here? This is where things are going to get a little weird. So, does anyone remember the process to get
Calc?
yes, second calc? Incredibly enough, it's the one called 0. So let's try to find that first one. Look at the bottom. Do you see I'm at x equals 0 right now? So if I just hit to the left, do you see how it just went flying by? See him? It's a very steep function, yes? So what I'm going to do, I can kind of keep an eye on my y also. Do you see where I am on the y? Even when you can't see the cursor, you know where it is. I'm way down. Let's see, when am I going to turn around? I still haven't turned around. Turn around, come on, come back. Come back, come back. Here we go, now I turned around. Now I'm coming back, I'm almost back. Do you guys see that? Because now I'm at negative 21, I'm almost back. And I just went past. All right, let me see if you guys are cool with this. I need you to understand. What's one thing I could do immediately? Because this sucker is really tall, yes? What can I do to make this better?
Change the zero
Window.
line max.
Yeah, go to window. Let's make y min. Let's make it at least negative 100 and make this at least 100. Let's see what that does for me. Still pretty steep. But that looks a lot better. Alright, so let's make it even a little better. Don't worry about this guy, we'll worry about him in a minute. So now if I go back to window, I'll make this negative 200, make this 200. Now let's see what it looks like. Alright, it's a little better. Okay, let's see if this can handle it. Okay. So let's try this again. Just bear with me. Why did I do what I just did? Because it's so freaking tall. So I just sort of looked up higher. So it visually just smooshes it a bit. So it makes it a little bit easier to see what's going on. If I go out a little bit more, I can even maybe see where it goes down. But that's the part. I don't care about that part. I didn't ask you to find the minimum. So let's do second calc 0. Now when I move, see how I can see it a lot better?
Yeah.
The steps are still as big as they were, it's just I can see more steps because I look up and down further. So now when I go, I shouldn't go zooming past. Because what's the first thing it's asking me? What does it want to know? Left bound. Okay, so here's how you always do these kind of things. Get the cursor as close to the answer as you can. Yes? And now it wants to know a left bound. So let me hit the left arrow once, twice. Enter. Now it wants to know a right bound. This thing is so needy. I go back to it, and then hit the right arrow once, twice. Now I'm definitely to the right of the answer, correct? Enter. So now you can see the little area it's going to search in. Can you guys see that? I don't know if you guys can see that. If you're doing it with me on your... Over this dude, I'm sorry. You gonna fall? Yes. Where am I? Oh yeah, now it wants a guess, right? So then I put my cursor as close as I can, enter, and now it's got the 0.
So the y doesn't matter at that point?
All I care about is the 0, which is another name for x-intercept. Oh, I see what you mean.
Yeah.
I'm with you. Do you guys see this as, for me it says 9e negative 11, which is the calculator's way of saying 0. Poor little dude, it can't resolve it well enough. So that is essentially 0. What's really neat is if you go on to take calculus, I'll show you the algorithm the calculator uses to do this. And one thing it does, it just keeps going until it's within a certain error tolerance. Otherwise, it might run forever. So it's got to say, when am I going to stop? Right? And anyway, we can actually, oh man. It took too long. Oh, dude, disconnected. So how do I find, so you can find this one the same way, yes? This one here. What about these two?
Zoom in.
Yeah, I'm going to use my favorite thing, Zoom box.
Yeah, I like that.
Zoom box, you come over. If you hit enter, it'll be one corner of a box. Hit up and over. Not that far, Jeff. Enter, and now it just zooms in, and I can see both eventually. There's one in. Ooh, I gotta zoom in more. Ooh. Then I can do zoom. I get, it's a little creepy how excited I get about it. So then down and over. Let's see if I can see these better. There's one answer. Yes. And look at that. That looks pretty good. That looks like it's an actual whole number there. Okay. So you've got the window you can control. You've got Zoom box, which is like CSI enhanced, except it's real. Right? Okay. Yes. Oh, it's just this one. From the test, from the practice test. Yeah. Oh, okay, it's the same thing. X to the fourth minus 0.3 x cubed minus 36.9 x squared plus 72.3 x plus 80.4. Bum, 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 bum. Oh, hit Zoom 6 to come back to Zoom. Now it looks like mine did it first. You were in a really weird window. Yeah. What weird is oh, right here. You left the next slide. And dear God, guys, on the day of the test, when you hit a technology problem like this, something weird's happening, you come up and see me. Sometimes you're borrowing a calculator and somebody else did something and he freaked everything out, so I can just put it back to normal for you, whatever. I don't want that to get in the way of you getting the problem done. You get syntax errors and whatever, just come up and show me. Yeah? Okay. Anything else? Yes. Number 3? standard form. What do I have to do? Yeah, go for it.
You gotta complete the square.
Gotta complete the square, that's right. Back, baby. Okay. So, oh shit, let's see. I don't know, is it this one? Oh, it's that one. That's okay, that'll work. So looking at number, let me change this. Document camera. Oh my god, so much multimedia. So I've got 3, where'd it go? X squared minus 18x plus 2. Where is my eraser? Is that it? Yeah. 'Cause that's trying to be an 8. But it wasn't quite successful. That's fine. It's fine. That's fine. Go away. Yeah, but oh, I don't like that. It's not fine. That one. Okay. Now you can go away. Go away. Okay. So help me out. What's the very first thing I have to do? In fact, can somebody just tell me? Let me start it off with a times x. What's standard form look like? Yeah, so I want to make that, look at me pointing again. I want to make this look like this. That's what I want to do. And this is the part that tells you have to complete the square. That's what completing a square does. It adds something so that it can be put into this little tiny compact form, yes? So what's the very first thing I need to do? What does completing a square require to be in front of the x squared? What should the first number be? Should be a 1. What is it currently? Damn it, so let me take a 3 out. Does the 3 come out? Oh, Jeff and a half. You're so awesome, dude. I'm so smart. It's amazing. Okay. Get in there. Go away. You go away. You go away. 6x, there we go. 3 doesn't come out of 2, who cares? Because I don't need to take it out of 2. I just need to do that. Because now I know what k is, right? Well, I know part of k. I don't know what k is yet. But this is going to become what k is. How do I figure out what goes here? Take half of negative 6. And then square. So I know I'm going to add 9 here. So what did I actually just do?
Add 27.
I added 27, yes? So I better do what at the same time? Subtract 27. So then I get 3 times, no thought involved. I know I have factors, no thought involved.
Minus 3 squared.
Minus
25.
35. So what's the vertex then?
3 negative 25.
3 negative 25, yeah. Maybe. And then the next part, I think I say verify using the shortcut. What's the shortcut?
B over 2a.
Negative b over 2a, what's b from the beginning? Negative 18, so negative 18 over twice a. 18 divided by 6 is 3, same answer we got for x, see? And then how do I get the y? I'll plug a 3 in, I'm going to get freaking negative 25. You guys with me? So if I say put it in the standard form, I did not say use the shortcut. I said put it in the standard form and then find the vertex. Don't find the vertex and then put it in the standard form. If you don't remember how to freaking put it in the standard form, get the vertex by the shortcut so then you can graph it so you don't lose points for that too. Only lose points for the stuff you don't remember. Don't lose points in the other stuff because you can get it a different way. Right? Maybe? Is that okay for that one? What's the y-intercept? 0, 2. So then you can get another one by symmetry, right? Around the vertex. Because that's where the mirror is. Okay. Oh my god, this feels so good. I like this. Sorry. You guys are like, whatever, man. Just shut up and tell me stuff.
Why are we subtracting 27? Oh, no, adding.
Because they're already added. So I changed the problem because I added 27. I better subtract it, so I overall did nothing. Or else I made a new parabola. So again, here's something you can do. This problem had a lot of moving parts. We had to complete the square, we had to interpret what we got, find the vertex, we had to remember the shortcut. Is there a part of that? Is there one of those things that doesn't make sense? Do you want to do another problem where we complete the square and something in that form? Do you want to do another problem where we use the shortcut? Do you see what I mean? So there were a lot of levels involved in this problem. You have to understand each one by themselves to be able to do this problem. Does everybody feel like you could complete the square the way that we did? Because you know I'm going to ask you. So if this is not a 1 right here, if that's not a 1 right there, that's the first thing you take care of. Take that sucker out. Don't take it out of the last two. Just move him over. Move him over. We just need to make room. Don't worry about that last number. Yes. You mean the first number 8 or the second number 8? Second number 8, okay. I love to show off my grasp of our number system as much as I can. 1, 2, 3, 4, 8, 5, 6, 7, 8. The one about math teachers in Townsville? Okay. First thing you want to do on a problem like this, and this should look familiar if you've done chapter 4, these kind of problems. Can you immediately find 2 points? Yeah, what's the very first point? In fact, how do you want to define your variables? What do you want x to mean? Because you have total control. Years. Good, even better. Years since, what was it, 1992. That's not a real year, Jeff. That's a mythological year. Shut up. Okay. And what do you want y to mean? Number of math teachers, yeah, or the math teacher population, or whatever you want to say. Or like amoebas, we just reproduce. Asexual, they just split apart. It's weird. So what's one point you can create then? X comma y. From the information I give you, what's the first point you can create? Yeah, 0 years since 92, there were 43 math teachers. Oh, in this problem, yeah, we're decreasing. Townsfolk are throwing us out. What's the second? Are you guys with me so far? If I define x to be years since 92, then 1992 is 0. That kicks ass, because what's special about this number then? What is this point? Y-intercept. So what's special about that number then? For a line equation. That's the value of b. That's b. Look at that. Look at us go. We barely did shit. We already know what b is. We got this halfway done. What's the other point? 12, because that's 12 years since 92 to get to 2004. 39. So I already know what b is. What's the only other thing I need to know? To get the equation of a line. Slope. Do I have 2 points? Dear God. If this is an untrue statement for you, this is bad. If they give me 2 points, slope is easy as shit. Right? You're like, give me a lot of those problems, Jeff, so I'm not going to. Ah. But you'll get at least one. So slope would be, what goes on top? All right, 39, I think this is what you said, minus 43? Or do you say it the other way around? It doesn't matter. So if I go this way, 39 minus 43, what do I put on the bottom? 12 minus 0. Or you go the other way, we'll end up in the same place. Why does this not sound familiar? We'll see if past Jeff did this one right. Damn it. Negative 4 over 12, which is negative 1/3. So do we know M? Yes. Do we know B? So do we know the equation of line?
Yep.
Damn straight. What's the equation of line? Negative 1/3 x plus 43. Because we know M, we know B. We know M. And then part B is easy. Where do I put 31? Math teachers.
Why?
In for y, and then you solve for x, right? I like it. Some of you guys are like, I'll tell you where to put 31 math teachers. Torture those. Yeah, it's time for payback. Put them in Squid Games. Stop. Squid Games, part 2. Nothing but math teachers. Oh man, sorry. I am curious now. How did past Jeff do this? Or is it just present Jeff's bad memory? Ooh! That's fascinating. Yeah, I made a mistake. That's awesome. I love it. I do like to prove to you guys that no matter how good at math you are, you can still make little mistakes. Anything else? I'm glad we did that one together. We're all better than past Jeff. Let me go ahead and give you guys the answer key. See if there's anything else that's an issue on there. I did 2004 minus 1992, and I got 8. Because I'm special. So everybody, look at number 8. Laugh at past Jeff. Look at it. Look at Jeff. Look at past Jeff. Getting 8. That's pathetic. So then this is wrong also. So let's do this one. So this should be. Oh man, where's my pen? Oh yeah, I'm taking it out. Negative 1/3 x, right? So then when I do this, this should be 1/3, which would make this become 36, which would make this become, I don't know, 2028? Okay, that's better, because then it's in the future. That makes more sense, Jeff. Okay. I know exactly what I did. It's a very common mistake. I did 2002 minus 1994. There's always a side. Which is one reason why I'll never say I don't make mistakes, because that sure as I don't do. And I'll never do Scantron tests. Because if you make a mistake like that, it's an understandable mistake. So you won't lose as many points. I'm much more interested in, do you know how to get the line equation? Do you know how to use the line equation, right? I was going to do the rest of this in class, and I probably should have, because I tried to jam it all in here. Oh man, there was my little dude. I think you can read this. Now, just to remind you guys, this problem, I don't know if you tried this problem. Very long ass list of stuff, yes? And I didn't really give you, I gave you an upper bound, that's all I did. So, it still left a lot to be guessed at. So on the actual test, I'm not going to do that to you. But Another practice test. I'm like, yeah, whatever. There's a really good point here, though. -2 worked, and then I used it again because if it works, it doesn't mean you throw it out. It could work multiple times. Now, real quick, Descartes' rule of signs. What did it say? There could be how many? There could be 3 or 1 positive, 2 or 0 negative, and I ended up getting. Yeah. Let me see. Can I read my own writing? I can almost read this. Wait, did I lose somebody? This is last dude. Oh, I lost my 1. Oh, is this my 1? Look at me go. That's a 1. Okay. So I got 2 negative and 3 positive. So that perfectly lines up with the prediction, yes? I got 2 negatives, 2 negative 2s, and I got 3 positive, which lines up with that possibility, right? Now, there could have been some complex, but it still would, it still lines up with the prediction. That was sort of like the bonus question on the quiz. So when are quiz corrections due? Tomorrow. Sorry. But the nice thing is, again, they're good study for the testing. So you know that kind of problem's going to be on. So you're getting points back and you're studying for the test tomorrow if you do your quiz corrections. Homework obviously is due tomorrow. Up through what section? Do you guys remember? 5.5. So Jeff faded very quickly. This weekend was supposed to be very different. And I was in my house the whole time, laying on the couch. It was great. Started feeling better last night. I was like, oh, good. My class will be so happy about that. Anytime there's no more questions, you guys can head out if you want to. That's fine with me. If there's any other questions, let me know. Oh yeah. Don't forget your IDs, everybody. Take IDs, please. Oh yeah, that looks familiar. So you got, what was it? -9 halves? Yeah, okay. Okay, looks good.
And then I changed GSY. I'm assuming it was just like conversion.
Which, so
For the end behavior.
Oh, okay.
and behavior. Oh, the Y. I got you. Okay, you're good.
Is that good?
Okay.
That was it.
I had a question.
Yeah.
Sorry.
How do you make sure like you found all the
Yeah, we were here like,
Oh, if you want to hang on to it, you can.
I was gonna say, can I just take a picture of it?
Sure. Or you can turn it in tomorrow. It doesn't matter. It's
Well, I
due
guess
tomorrow, so you got time yet.
Okay, cool.
Maybe like to make sure that you found all the possible routes so you didn't forget.
Not really. It's not a quick way because you have to put them all together. So you get all these guys now. Oh, well, there is something you can do for the top. Let me see. It depends on if you. I kind of showed you guys this. So it's 48, right?